Okay, so here's you guys' solutions to the second problem set. I told you I'd post these so you can take a look at them if you had any questions. So number 13 again, we kind of read through it. Part A. For A to win the election outright, we got to reassign these remaining 30 votes. If we try a couple things, if we say, okay, well, let's give A all 30. That's going to bump them up to 56. Next closest person's 42. So we know if we give them all 30, it's going to work. We want to find at least how many of them. So let's play around with some different numbers. Let's give A 20 of the votes. That'd put them at 46. Now, B's not a threat. C's not really a threat. So let's give those remaining 10 to person C. That'd put them at 52. So if that happens, person C would be the winner. So 20s are lower bound, 30s are upper bound. 30 works, 20 doesn't. So now we just kind of need to play around with it a little bit. Let's try 25. So if we give person A 25 votes, they're up at 51. If you give person C 5 votes, they're up at 47. So A wins, but there's still some room there. So now we've just shrunk the interval we need to 25. 25 is too much, so let's try 24. That would put them at 50. Give the remaining 6 to person C, they'd be at 48. If you did 23 and 7, they'd tie. So we can say with confidence they need 24 votes, because that would be 50 to 48. You're going to do the same exact thing for part B, but you want C to win the election outright. So for part B, you want C to win. Think about who's their biggest threat. It's not A anymore. It's person D who's the biggest threat. So you're going to play around with some numbers with C and D, and what you'll find with that is you need to give 12 votes to person C. Next question. We've seen one of these kind of before. There's 110 voters. There's an A, B, C, and a D on a ballot. We're using board account. Maximum number of points a candidate can receive. If they want the maximum number of points, that would be all first place votes. 110 people, 4 points each one, they'd get 440 total points. What is the minimum number of points a candidate can receive? That's all last place votes. 1 point for each last place. 1 point for last place. 110 people voted, so minimum of 110 points. C, how many points given out on one ballot? There's 4 people, so start at the bottom. Give them 1 point each. We go all the way up. 4 plus 3 plus 2 plus 1. 10 total points. Total number of points given to all 4 candidates. Well, each ballot's going to be 10 points. There's 110 ballots, so this is 1,100 points. If A gets 320, B gets 290, C gets 180, you want to know how many person D got? All you got to do is solve this little equation here. And D ends up with 310. Next question, 29. You get a preference schedule, and we add all these up. There's 24 total people who voted, 5 different choices. We want plurality with elimination winner. All we care about is first place votes. This is the only place we look. A has 8, B has none, C has 2, D has 13, and E has 1. If 24 people voted, 12 and 12 would give you 50%, which isn't a majority. So you need 13 for a majority. Right there, D wins it. You don't even have to do plurality with elimination. Then the questions, the answers to them just fall right in. Why can the winner be determined in the first round? Because they got a majority. Explain why the plurality with elimination satisfies majority. If you have a majority, you have a plurality. Because you do plurality with elimination until you find a majority. Okay, but it doesn't work the other way around. If you have a plurality, does not imply you have a majority. Good. Next, 33, another preference schedule. We add up the total number of people who voted, and we get 17, 27, and 4 is 31. So if we cut this in half and we round, we need 16 for a majority. Same idea, plurality with elimination. So we're going to go A, B, C, and D. Count up first place votes. That's all we care about. Person A's got 10, B's got 9, C's got 5, D's got 7. No one has a majority, so C's gone. We need to reassign their votes. They go down here to person D. So person D gets a +5. So round 2, it's 10 to 9 to 12. No one has a majority still. So person B is gone. We need to reassign their votes. So they're gone. Person C should get their 4 votes, but person C is already gone. So they're gone again, and D gets those 4 votes. So D gets a +4. Person B is gone. They should go to C, but C's already gone. So A gets +5. When you get to round 3, you got 15 and 16. D's your winner. Hits your majority. Right? Next, Condorcet candidate. The Condorcets are head-to-head. So we're going to list out all the matchups that we can have. That's a D there on the end. All we care about are those people, though. So I'm not going to go ahead and do all these. I'll just show you guys how to do 1 or 2 of them. So if we're doing A versus B, this is all we care about, A's and B's. All right, I'm just going to add up person A. They get 10 of them here. B's ahead, B's ahead. A gets 5 of them here. So that'll put them at 15, and B's ahead. We said there was 31 here. So if A had 15, B's got to have 16. If we add them up, B's the winner. So if we're doing A versus C, you're only looking for all the places where A and C are on the ballot. So we only care about this, 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 and this. Now I'm going to go ahead and just circle all the winners. You guys can count them all up. A versus C, A wins. A versus D, D's a winner. B versus C, B's a winner. B versus D, B's a winner. C versus D, C's a winner. B's your winner. It won 3 head-to-head matchups. But the person who won plurality with elimination was person D. So they won one method, they lost the other. The results of this imply a violation of which fairness criteria? Condorcet. You won plurality with elimination, but you lost Condorcet. Is it fair? These are questions. Last couple, 51, a little bit of a different problem. It asks you to sum the numbers 1 to 500. If you looked on that video online, there was this Gaussian summation formula that was this. You want to sum 1 to n, you go n times an n plus 1, cut in half. There's a little proof that'll show you how to do this. So in this case, this just means sum. It's just Greek. We want to take 500. N plus 1 would be 501. We cut it in half. That's how we get there. So if you want to sum the numbers 1 to 720, it'd be 720 times 721, cut in half. Last two, and I'm just going to do 55 here because 56 is the same idea. There's 15 candidates in an election. How many pairwise comparisons? Of the 15 people, we just want to match them up with everybody else. You're just trying to make different groups of 2. The order doesn't matter. That's why we cut it in half. It doesn't matter who A, or when we compare A and E, if we compare E and A, it's the same thing. So what this comes out to be is 105. So there's 105 comparisons. 15 people, you're just making groups of 2. Now, part B, if it takes 1 minute to calculate a pairwise comparison, how long would it take to calculate the results? So we get 105 pairwise comparisons. We can do one pairwise comparison in 1 minute. It's going to take 105 minutes, which is 1 hour and 45 minutes to completely do that with 15 candidates. 56 is the same idea. So hopefully that helped you guys out a little bit with problem set 2.